let me know if you can hear me all right in the chat. And without any further ado, let's just kick it off. So welcome to Build Your Own CDN in under an hour. This will be very much like a cooking show where there's a lot of things happening live. Most of it happens live. In the end, you'll have a decent meal. There's a fixed set of recipes. There's some ingredients that we require, but there's always some magic. And today will be no different, because how am I going to build a CDN in the remaining 59 minutes? So I hope we don't burn the food, and I hope the meal will be delicious. And that being said, hi, I'm Thijs. As you can see in my name, I am not English, not a native speaker. I'm a Dutch-speaking Belgian, and I'm the tech evangelist here at Varnish Software. And first of all, I would like to say thank you for being here, because remember back in March, early March, when the pandemic kicked off, webinars were pretty cool. Now we're end of June, and webinars are no longer cool. It's a bit corny. So with that being said, the fact that you have all these options of choosing webinars out there, so much happening, and you chose to be here with me for the next hour, me, myself, Thijs, I appreciate that, but the company Varnish Software appreciates that as well. Varnish Software, for those who don't know, is the company behind a very popular open source web acceleration software called Varnish Cache. We don't just offer Varnish Cache. Varnish Software also builds a commercial version on top of Varnish Cache called Varnish Enterprise, and it adds some pretty interesting features that tackle specific use cases that are enterprise worthy. All of our software, both Varnish Cache and Varnish Enterprise, is available on premise, but also as ready-to-use machine images in the cloud. We have become somewhat of an industry standard when it comes to web acceleration and caching. About 4.8 million websites use our technology. Those are the ones we could measure. Of course, there will be plenty more that don't expose an X-Varnish header that we can use to identify them. But 4.8 is a pretty good number, and we're really proud of that. When you look at the top 10,000 websites, about 19% uses our technology. And historically, people always knew us from the web and API acceleration. But more recently, last couple of years, we see that most of our clientele is aiming towards CDN use cases. So the CDN vertical is pretty interesting to us. The fact that you can do it yourself and get the software is a compelling argument, and you will see throughout the presentation. Now, it's not just about caching images in the CDN or static pages or some PDFs. No, we can even handle full-blown video. And video has become a major use case for us. And my demo will also include an HLS, which stands for HTTP live streaming video platform. If we know that 80% of the bandwidth over the internet is video related, you know video is a pretty big deal. Now, the first three use cases, the first three verticals, make sense. What seems to be surprising for most people is that we have a web application firewall component. We are known for protecting your origin from excessive load, but we can also protect your origin from potential intrusion attempts and malicious requests. Unfortunately, we do not have time to dive into all the features. There's a couple of key feature categories that I do want to highlight. First of all, we're built for performance. That is our primary objective, our main priority, and we don't compromise on that. We can quantify this. We can easily process on a single Varnish machine about 100,000 requests per second. And when we translate that into bandwidth, we can process about 150 gigabits per second on a single machine, which is quite a decent number. And internally, we can process a cached object in about 30 microseconds. So that's a big deal for us, and we will continue to focus on that. But when you build a CDN, you need storage. When you have millions of objects, maybe even video, images, PDF files, and what have you, you need storage because it's not going to fit in RAM. What we offer is a specific storage engine called the Massive Storage Engine, which is specifically built for caching. Mind you, in our minds, we know that disks are the slowest part of our setup. Here it's no different, but we found a way to make sure that you can benefit from the performance of memory and still have the reliability of disk without suffering from these typical trade-offs, the typical slowdowns that you have from opening up files, from iterating over directories, the disk fragmentation that occurs. You will see throughout the presentation that we have a pretty interesting solution, and most of our CDN clients see that as the key feature. What I also like, I'm a longtime Varnish user, is the personalization. As a user, I always appreciated the level of customization that we had, and that is due to the Varnish configuration language. Varnish doesn't just have configuration files. It comes with a full-blown programming language. Now today, we are going to build our own CDN, and that begs the question, why would you do that? Why would you build your own CDN, knowing that there's plenty of commercial alternatives that offer this as a service without the added complexity? Now, for most of our clients who build their own CDNs, it's a matter of control and a matter of predictability, which is not always the case with these big as-a-service platforms. Now, this is not me dissing those companies. They offer valuable solutions, and they're even partners of ours. Most of our clients who work at a tremendous global scale will combine multiple CDNs and have a local CDN, have a hybrid solution. So if you have more control and more predictability, that applies to in terms of stability, making sure everything is up and running at all times and have control over all the bits and pieces, but also have predictable budget. This is a dedicated CDN solution. This is software that you're getting with which you can build your own CDN. It's just for you, it is not shared. And it's ideal for companies who are willing to increase the coverage in locations where your CDN doesn't have any points of presence, or when you already have the infrastructure and the network and you just need the software. I hope in about 55 minutes you'll agree with this statement, that setting up a CDN is not all about caching. The caching effort is about less than 20%, I would say, but all the effort goes into networking, infrastructure, connectivity. That seems like a good punchline, a good quote, but you'll see that it's very, very true. Speaking of which, this is what we're going to build today. This is our CDN, if you will. At the foundation level, we have an origin server. We actually have two. We have one in the EU and the US. And if you pay close attention to this, you'll see that everything is color coded. So everything that is brownish will be hosted on AWS in the cloud, but in their EU region, more specifically in Ireland. The blue parts are hosted in the United States at Azure. So we're upping the complexity by having multiple cloud vendors here in their East Coast data center. And all of these endpoints will be presented to the end user under the form of a www record that is managed through AWS's Route 53 GeoDNS. Depending on your location, you will either get an IP in the EU or an IP in the US. As you can see on top of the origin, there's two edge servers in each region. These are our Varnish caches. We call these the edge because that is the outer tier of your web platform. This is where all the loads will be managed. And on top of that, there's load balancers to make sure that there's an equal distribution of the load, but also high availability if one of the servers would go down. So that is what we have. Of course, there's a traffic router. It's in gray. It is not part of any cloud, but I'll get to that all the way in the end of the presentation. So we're 7 minutes in this, time to get the show on the road, time to start doing things. So I'll exit the slide deck, and most of what we'll be doing will be done in the browser and on the command line. Let's present our origin application. As you can see, there's a fixed naming scheme, DIY CDN varnishsoftware.com, and then we have a set of subdomains that we'll use. I hope the font size is okay. I hope this gets shared all right. So when I refresh the page, this is a trick I always apply when dealing with caching, you see that the timing gets updated. This means it is not cached. If this page were to be cached, that timer wouldn't move. This is hard-coded into it, the EU origin. Eventually, you'll have a US origin as well. There's a background image, there's a logo here, there's some CSS, some JavaScript, but what is also there is that big video player. If I take you to the source and we zoom a bit, you will see that this is nothing more than an HTML5 style video tag and a source attribute where we will do all sorts of things. And to switch this up for a second, and you will see that everything gets loaded from /hls/main.m3u8. This m3u8 file is a playlist file, which is part of the HLS standard. HLS is the most popular HTTP live streaming format. So that is how things are composed, and that is what we need to accelerate. So what I will do now is I will show you that video, and Ariana, who is my colleague, who is also in this chat, will share the EU origin URL. The reason why I would advise you to have a look at this is because the GoToWebinar software will hardly do it justice. In our experience, we know that these videos will look pretty bad at your end because we don't have the frame rate on GoToWebinar, nor do we have the resolution. So by now, Ariana has shared it. And you can see this is just open source video, royalty-free, the Blender Institute. What we did in terms of modifications is we labeled it with EU, if you're in the EU, and video that is hosted from the US will have US on it. Now, what is exceptionally interesting about this is if we start inspecting whatever's happening here, we go to the network tab, go to XHR, which will load AJAX requests loaded by JavaScript, and I refresh the page. First thing that happens is the main.m3u8 gets loaded. I told you in the beginning, that is our playlist. Well, if I open it up and I look at the response, this is nothing more than line delimited data. And it has a whole lot of information, most of which is just timing of these transport segments. These are video files. So that's one big video file chopped into little bits and pieces, and plenty of them. When I go all the way down, we can conclude that this video contains 443 segments. There's some meta information above on line 5, where you can see that every little segment is 3 seconds. So the browser or the video player is clever enough when it reads that main.m3u8 to make sure for every 3 seconds a file is loaded. And I can prove that now. When I start playing this video, you can see that all these little bits and pieces are loaded. And as you may realize, maybe by this time the server is high and low because all of you are trying to connect. And that might even be the goal. Like if we crash this, we have the perfect use case for a CDN. So right about now, it is time to create the CDN and create those edge nodes. So if I go back to my slides very quickly, you might see that you have EU Edge 1, EU Edge 2. These are the ones we're going to create now. So I'm going to my instances here. You have the origin, you have VCS. Origin, that's the origin server. That one you know, that one you have been consulting for the last couple of minutes. VCS is a more mysterious server. It is the Varnish custom statistics server. It's a sort of centralized machine that grabs timing and gauge data, and we'll use that for dashboarding. So we're going to launch instances, and typically on an AWS, you would pick an operating system and install whatever you need. I'm not going to do that. I'm going to make my life a little bit easier, and that is something you can do as well. Our images are available on the cloud. So if you click AWS Marketplace and you type Varnish Enterprise, you'll end up with a couple of images. These are our machine images that we maintain. We make sure there's bug fixes, updates. I'm going to select this Ubuntu one, and then it's a matter of selecting which machine we're going to take. What is interesting about this is this is our full-blown commercial product, and you don't have to pay license fees up front. There is a little bit of a software cost, but that's added on top of the hourly cost and handled by AWS. So you don't need to have a relationship with us to use this. It's flexible, it's pay as you go. If you want to scale, you can scale. If you just want to shut machines down, you can do that without having this capital expenditure or operating expenditure. We're going to choose the size of our machine, and there's a bunch of them here, but since we're building a CDN, I'm going to go for storage optimized servers. There's plenty of them, and I've put my eye on this one. i3 2X large, 8 cores, 61 gigabytes, 1.9 terabytes SSD, which is NVMe SSD, and 10 gigabits per second of traffic. That will do for this one. So we're not going to go for one. We're immediately going to configure 2 machines. I don't want to do this sequentially. The storage is good, 8 gigabytes of root disk. We'll hardly use any of it. And then the big one here, 1.9 terabytes of NVMe SSD. In order to recognize these machines, to find them back in our overview, I need to tag them and give them a name. I have a naming scheme, which will be prompted here, DIY, CDN, EU, and that is our edge node. Next step is security groups. This is where we do all the firewalling. I don't need to do anything because the machine image, the Varnish Enterprise Ubuntu 6.0.6.5 release, comes with preset security groups. Review, launch, confirm that we have the SSH key to log in, and we're good to go. And now it's a matter of waiting a couple of seconds before AWS picks this up. And there we go. Our instances are launching. They're not done yet, so I have to do some other work in the meantime. I'll make my life easier by giving them numbers, Edge 1 and Edge 2. The next step is making sure they have DNS records. So if I click Edge 1, I can copy the IP address, go to Route 53, which is the DNS management tool of AWS, the one that has geo availability. Create the record set, call this EU Edge 1. Lower the TTL. You won't be doing that in production, but for the flexibility I need in this demo, I'll lower the TTL. In real life, you'll probably set that to an hour. Create the record, create it, secondary server, Edge 2, copy the IP, create the record, EU, Edge 2, lower the TTL, paste the value, done. So at this point, we have our 2 edge servers. We have the infrastructure part. We still need to set this up. But if I go back to the slides, I promised you that there would be US zone as well, hosted on Azure. And if you look at my Azure panel, at this point, See what happens here. There's nothing in there, and I don't have the time to do this manually. And this is where the cooking show magic starts kicking in. I've prepared some things. I will automate this. So what I have in my right here is a set of Terraform scripts. Now, Terraform is an external tool. It has nothing to do with us. It's a third-party vendor-agnostic cloud orchestration tool. So it's not really tied to Azure or anything, but it's convenient if you do multi-cloud stuff, you can define it. And I'm going to quickly show you a little bit of code. This is just declarative syntax in which I will just mention everything here. So now I can do Terraform plan minus out plan.out. And at this point, it will start calculating things. So what was happening is it's connecting to AWS's Route 53 and to Azure, and it will do the delta based on the current state and figure out what needs to happen. So at this point, it knows it needs to take 27 steps, ranging from setting up a virtual network, creating subnets, assigning public IP addresses, doing the load balancing based on network security groups, and eventually also, let's go here, create the edge servers, edge 1 and edge 2. So now, I'm going to clear the screen for you. I'm going to execute this. Terraform apply, and then use plan.out. This will take a couple of seconds. It has the execution plan ready. And it's created. And now we have plenty of time to do other things. The next thing we'll do is create that load balancer, that EU load balancer. Now, the load balancer here, the edge servers, the origin, that will happen automatically right now. It will even register the DNS record. The only infrastructure component that we still need is this one. So we're going back to AWS, to our instances, and instead of, I can go to load balancing, but first I'll create the target groups. These are groups in which I will group my servers, and those will accept traffic. DIY, CDN, EU, HTTP, this is called. This will accept HTTP connections. As you can see, the value is preset, but this might sound counterintuitive, but I will change this to TCP, and I'll explain later why that is the case. I don't want to deal with HTTP directly. Then it's a matter of selecting the nodes we need, confirm that they're on port 80, include them as pending, and create. So at this point, we've just created a target group for HTTP. I'm going to do the same thing for HTTPS. Naming scheme is consistent, DIY, CDN, EU, HTTPS. And again, we're going to go for TCP on port 443. The reason for that is, and you'll see that in a second, is that I do want to terminate TLS on my machines. I don't want to do this at the load balancer level. And I'm going to select a specific kind of load balancer to do the job in just a second. So this is where we accept HTTPS connections and send them to the two servers. This is for HTTP. Now we click load balancers and create a new load balancer. So normally I would go for this application load balancer, but that forces you to terminate your TLS certificate here, and I don't want to do that. I have all the measures in place to do that on my Varnish machines. So I'm creating it here. I'm giving it the consistent naming scheme, DIY, CDN, EU, and we're going to have two listeners, one on port 80 and one on port 443. I'm okay with hosting them in their 3 data centers in Ireland. It's fine. In terms of network security, I don't have to do anything. In terms of routing, I do have to select the target group I just created. So I'm going to set the HTTP one. All is good here. Register the targets. Those were the ones I selected in the target group. Review, create. And now I just scheduled creation of a load balancer. There is one option I wasn't given. I need to correct something. If I go to listeners, I was only given the opportunity to select this one, HTTP. This is for HTTPS, so I need to change that. Select the other forwarding group, update it, and we're done. We just created a load balancer. It's almost ready. But what I need to do now, and that is quite important, is I need to make sure there's a DNS record because this is the host name. So we're going back to Route 53. And when I refresh, there'll be more stuff in there due to automation. So you already see that there's a US endpoint, us.diy.cdn.varnishsoftware.com that points to the Azure load balancer. There's even a www record that points to the same load balancer, that is geographically targeted to North America. So if you're in North America, Canada, United States, you will automatically be routed to the US. So I need to do something similar here. I'm going to create the EU endpoint, which is not an A record. So we're not assigning IP addresses, but a canonical name, CNAME. Lower the TTL, paste this value, and create it. Now, in order to have true geo distribution, I need to create another record, call it www. There's already one there for the US. CNAME, lower TTL, paste value, but then we need to adjust the routing policy, set it to geolocation, and go for default. I'm not going to specifically target it to the EU. This is my backup location. So if you're in the United States, you'll end up on the US. If you're anywhere else in the world, you'll end here. Now, in real life, we'll probably have an Asia Pacific zone as well and something for the Middle East, but we don't have time or resources for that. So that is done. We're about 20 minutes into this. The next step is going to be deploying the VCL to the EU. So I have a script here. I press the button. There's a little bit of magic. What it does is it parses EU values into these files and then sends them to my 2 edge servers. But I will show you what the parsed value will be. So here's my editor. This is the VCL file. Now, a VCL file is a file that is read by Varnish on startup. And all these values that you can see here, which are written in the Varnish configuration language, will be parsed, will be compiled to C, or transpiled to C as they call it, and then will be compiled to machine codes and will be loaded into Varnish. So this will be extremely fast. But because C is quite hard to understand and to use, we've invented this Varnish configuration language. It's very declarative. And what we're doing, first of all, is importing a bunch of modules, the standard module, an HTTP module, so we can perform HTTP calls from within VCL. And the goal for me for showing you this is that on the one hand, you understand what is going on behind the scenes, but also that you appreciate the flexibility you have. You can actually program in this thing. So this is the massive storage engine module that allows us to make decisions on where on disk things will be cached. This is the MaxMind database module. This is a geolocation module provided by that wraps around the MaxMind library. MaxMind is a company that is famed for its geo associations. So it gives you a database that maps IP addresses to geographical locations. We'll use that. This is the throttling vmod, and in the end, this is the Y-key vmod. The Y-key vmod is the successor of the X-key vmod. So yes, we are good at naming things, and it's actually used for invalidation based on tags. So let's go through. Let's start at line 10. What you will see here at line 10 is a structure in which we define the backend. That's quite important because if we go back to our slides, to the overview, when something is not stored in cache, neither in edge 1 or edge 2, it needs to connect back to the origin, and Varnish needs to know where the origin is. So we've defined this as EU origin. You're familiar with that one. You've been to that one on port 443. This is TLS. This is protected. And this is a Varnish Enterprise feature. You don't have it in Varnish Cache. Next up is VCS. I won't spend too much time on this. This just connects to our VCS server, extracts information, and presents it in a format that is usable by our Varnish Live application, which is a dashboarding service. I'll show that near the end. Line 21 is interesting because it's yet another include. It includes other pieces of VCL, and it hides complexity of this VHA6 script behind the include rather, which is quite convenient because VHA6 stands for Varnish High Availability version 6. So that's our clustering, replication, and high availability tool. Most of the complexity is hidden away behind the include file, but as you can see here, there's a little bit more. Line 23 starts with sub. Sub stands for subroutine. And you will see there's plenty of subroutines. And that's the nature of the Varnish configuration language. It is not a top-down programming language like many others. It's a language where you extend behavior. There is a finite state machine that goes from state to state, and you extend the behavior. In VCL init, that is what's happening before a request is accepted. We can initialize a bunch of modules. First of which is MMDB, MaxMind database. We initialize it with a path of the MaxMind database containing IP addresses and country information. We associate this with the GeoDB object. And then next is a set of VHA6 options. There's a ton of those you can configure. You can tweak it to your exact needs, but I only need 2 for the sake of this demo. The secure token, I've changed it to not the most inspiring secret key. Please change this in production. And which servers should be replicated. So I'm using a broadcaster group. I'm mentioning that I only want to do this in the EU. I only want to replicate within the EU. The reason why I want to do that is because if I start replicating content, if an object is stored in cache and I distribute that and I replicate that to the other nodes, I might have to do like very long distance replication calls. I'm not sure what the impact will be in terms of latency. I'm not sure if my clouds have peering agreements, so that might be very, very stressful. I don't want to deal with that. So I'm relying on intra-region replication. And the reason why this is called the broadcaster group is because we're relying on the Varnish broadcaster, which is a tool that we've developed ourselves, part of the enterprise offering, is shipped with the image here. And that tool, that utility, is responsible for broadcasting messages to multiple Varnish servers based on an inventory. And the inventory has individual nodes and group names. The nodes in the EU Edge group are conveniently grouped under this umbrella. The broadcaster is primarily used for if you have to warm up your cache, or if you want to invalidate the cache and have a multitude of servers. This makes life easier. And we tend to eat our own proverbial dog food. We don't want to reinvent the wheel. We have a tool that is great at distributing messages across a given set of servers, so we use that within our VHA6 offering. And then it's just a matter of calling VHA6 token and we're good to go. This is the receiving subroutine. This is where we extend the behavior when you receive a request. First of which is by offering purge capabilities. Purge is a custom request method. It doesn't exist in real life. We use that one. Normally, when you access a resource, it'll probably be over GET or over POST. And if you have an API, put and patch and delete will also be there. So we are offering support for a request method called purge. So there's a request object with the method. And if it's purge, we want to purge. What does purge mean? Well, that means removing objects from the cache. So this logic is intelligent enough. When you do a request and you use the specific request method purge and you don't mention anything specific, you'll end up in the else clause and we will return purge. We'll send you to the purge stage where for that URL, the object will be removed from cache. Now, mind you, in production, there'll be security features enabled here like access control lists and more of that. For the sake of this tutorial, I made it easier on myself. I was a bit lazy. The problem with invalidating individual URLs is that it gets tedious if you have to do lots of invalidations, or if you have a piece of content, like the typical CMS complicated content, where when you change something in your CMS and you don't really have a clue how many URLs will have to be infected. So what we can do as well, on the other way around, is leverage YKey, this YKey module. And what this does is it uses tags to invalidate. And I'm going to show you in the content that we have right here how that works. If you go to inspect and we go to the network tab, go to doc, which will show us the document, and we click here, go to the headers, you will see a very specific response header called YKey. So we set that deliberately to give Varnish the tags we want these pages to be tagged with. So this is considered a page and HLS, and other parts of our application can also emit tags that Varnish will accept. So if we want to invalidate based on a tag, we can do a purge call and inject a custom request HTTP header called YKey purge. And I'll do a demo of that later on. And this will contain one or multiple tags and the content will be purged and we will know how many objects are gone. And then it will parse it in here. It will return a synthetic HTTP 200 saying we've invalidated X amount of objects. That's how that works. We'll show that later on. On line 39, we're hinting the backend. So that means we're telling Varnish to which backend it should connect. That's EU origin. We defined that here. So that should be crystal clear at this point. Here's where we leverage our GeoDB object, MaxMind database. We get the country code and the country name based on the client IP address, which is a variable in Varnish. And the output for me will be BE here and Belgium there. Depending on your location, that might differ. And we'll leverage that to do geo-blocking. Now, I have to admit, again, for the sake of this webinar, this is a bit artificial. If in real life, this won't happen, but I deliberately created an endpoint here that I'm intercepting called /geoblock. If you're accessing /geoblock and you're not in Belgium, like myself, or not in Italy, like my colleague Ariana, you will see this synthetic 403 content only available in Belgium and Italy error. We call this synthetic because it doesn't originate from the origin server. It's something we generated ourselves. And we do the exact opposite thing here with GeoBlock 2. When you're not in the United States, you can't see it. It's just something we do in a couple of minutes, and I'll show you how that works. There's rate limiting also in a very artificial way here. If you go to /rate limit, and for your client identity, which is your IP address, you've done more than 1 request per second, we are going to block you for the next 5 seconds, and we'll return a 429 too many requests error. So that's how that works. And finally, the last thing I'm going to show you here is prefetching. It's something we do for video. There's implementations as well where you can leverage the link response header sent by the application to load CSS and JavaScript. I could have done that, but instead I opted for doing prefetch for video. So I'm going to show you yet another thing by inspecting here. If I start this video, you see that a whole lot of these transfer segments are loaded, and they're sequential. 14, 15, 16, 17. So if we prefetch, we can easily guess what the next value will be. And that is exactly what we're doing here. If the URL starts with prefetch, we're trying to guess the next URL. And if anime 001 was the first one, we'll get 002 too. Because we know from the context, if the video plays, it's better to have the next segment in cache before the user requests it, because that will lower latency and will increase the user experience. Okay, let's carry on. We'll glance over this. This is just boilerplate stuff. I do want to focus on this subroutine, sub VCL backend response. This is what you get back when the backend has responded. So that means it wasn't stored in cache, we had to fetch it, and now it gets returned. And here is where that Y key header is processed. Remember when the application sent a Y key header with the values page and HLS? Well, that gets intercepted here. If the backend response object containing backend information has an HTTP header that it collected containing the Y key header, well, then we know we have tags to register. And if you have multiple tags in one Y key line, we use comma space separation like we did in the application, and we'll store them. What we'll also do is explicitly define an all key to every little object that comes in before it gets stored. So if you want to flush the entire cache, you only have to do a Y key call with the all key and everything is gone. Let's scroll down. Here's where it gets interesting. When you receive a response that originated from a backend request URL that matched this regular expression, so that means if your URL ends with M3U8, we're pretty sure we're dealing with an HLS playlist. So we're tagging it as HLS as well, explicitly in VCL, and we're adding a playlist key. So that way we can invalidate either the playlist or everything in regards to HLS. We lowered the TTL explicitly. Normally you would rely on cache control headers, but here we're lowering it explicitly to a single second. For video on demand, that doesn't really matter because the M3U8 file is stable. But when you have live streaming, that playlist file constantly gets updated with new transport segments. So you want to keep that as low as possible. We don't want to serve objects past their TTL, so we'll set the grace to 0. And we don't want to store this on disk solely in memory because the object is so short-lived. And we're exposing this through a custom backend response header called Varnish storage to indicate to people who are interested in that this object is stored in memory. We'll see that in a minute. We do something similar for backend requests or responses that originated from a backend request URL that match the TS extension. These are our video files, transport segments. Again, this is HLS, and we'll also tag it as TS. But instead of only caching it for a second, we'll be caching it for a day. Because you might know, as soon as the origin spits out the TS file, it won't change anymore. It's stable. So we might as well want to cache it for a day. And we don't want to serve it past the grace period, past the TTL. Because this is something we cache for a long time and it gets big in size, we'll store it on disk. And the same thing happens here. So that's the VCL file. That's how that works. We're already like 35 minutes into it. Let's actually set up these services. Again, we need to apply some trickery. I'm going to do this manually, but I don't have time to set up the 2 servers individually. So I have 2 split screens here. I have split screen. And when I click enter, it will go onto these machines. And the only thing I need to do right now is to enable broadcasting. So you can see if I do hi, everyone, you can see that this is duplicated. Hope you trust me by now. And I'm going to move this away so I don't have to sacrifice any useful screen real estate. And I have a set of commands that I will execute. So let's have a look. First command is where I download the Maxmind database. I've hosted it on my Dropbox. There we go. I've downloaded it. It's good. And then I need to extract it. These are the parts where everything can go wrong, and the demo gods, knock on wood, have been kind to me till this point. The next part is an important one. So I'm going to clear my screen and I'm going to paste this command. What this does is it saves this content into the etc varnish mse.com file. This is my massive storage engine configuration, and this is the part where I'll explain you how MSE works. So in this file, we define the properties of our massive storage engine. You have this env data structure in which you define your environment. And what I do here is I just uninspiringly named it my env. Up until previous versions of Varnish, you would set the memcache size to the fixed memory size you want, like 80, 60 gigabytes, 100 gigabytes, depending on what you have. As of recently, we've provided auto memory management, and we codenamed that project. The nickname of the project is the memory governor. The memory governor will make sure that the total cache size varies and it respects a threshold, and the default threshold is 80%. So 80% of the server's memory is allocated to Varnish, and the memory governor will make sure everything is stable and that the memory you need at runtime doesn't make you go out of memory when you have a big cache size. But it's not all about memory, it's also about persistence. So we have books for that and stores. The store are just raw storage devices, and they contain all the objects. The books, however, are databases. That's a metadata database. It's hosted here on Data MSC Book 1, and its memory mapped file. It is lightning fast, and it is a gigabyte in size. It contains all of the metadata, such as band lists, journaling, headers, timing information, cache variations, all of that is in there. And as soon as you start hitting this, we'll tag it with disk. And this should ring a bell because our TS files were supposed to be stored on disk based on a tag. Well, this is the tag. It applies to both stores. The stores themselves just contain the object payload, the body. And the interesting bit here is that there are pre-allocated large files. Store 1, hosted in Data MSE, is 900 gigabytes in size. And the same thing works for storage 2. So in the end, you have 1.8 terabytes of object storage. And the typical things that will slow you down if you start storing individual small files on disk is that you need lots of directory iterations, lots of file openings. At scale, you might run out of file descriptors. You'll have lots of fragmentation on disk. We don't have any of that because we have file system-like behavior in a single file. This file gets opened up when Varnish starts, it doesn't close, and all the data is streamed through that single file with intelligent algorithms and also with an intelligent way to keep 20% based on a high watermark of the cache available for new storage at any point. As soon as the 20% is surpassed, an algorithm kicks in and removes the least recently used content to make sure you always have space available. So this is high performing stuff. Given the fact that it's hosted on an NVMe SSD disk, you will not feel a performance penalty. Now, it's important to know that memory is the primary access point. If something is not stored in memory, the disk will be the secondary origin. I hope that is clear. That was quite technical, but I hope that is clear. What we need to do now is we need to make sure that these paths, Data MSE, Store 1 and Store 2, they exist. And we need to perform a little bit of magic here. So I'm going to run an mkfs command on dev nvme 0 and 1. That represents my disk. That is a disk on this server that is unformatted, a raw block device. So what I've done now is I've created that and it's formatted with XFS. We need to mount this to data. So data needs to exist. I just created a folder. And then we're going to mount the disk onto the mounting point. So with this command, dev nvme 0 and 1 gets mounted to /data, which just happened. We also need an MSC folder within data. But before I do that, I'm going to prove I have a disk. df-ah will display all my disks, and we're going to grep for data. As you can see, there is a data mounting point, 1.8 terabytes in size, and it's pointed right there. So that's good news. The next thing we need is we need to create the MSC folder. And then the final step is to make sure that all these files are automatically created. Let me clear the screen right here and paste it for you. So what happens is this is a custom make file system binary that we ship with the Varnish installation, specifically for MSC. You register the configuration, it reads all the values, and it starts creating all these files. And I can prove that. When I do ls-lh on data MSC, you see that store 1 exists, 900 gigabytes, store 2, 900 gigabytes, and the book. If you care about what the book is about, It has log files, the data, ban lists, journals, all of it is there. We've just set up the massive storage engine. Next step, still a couple more steps to go, bear with me, is we're gonna set up the nodes configuration file. We're gonna set up the inventory for VHA and for the broadcaster. So we've just, I'm gonna show you that, etc/varnishnodes.conf, we just inserted these values and we've grouped them. And that again should ring a bell. This is EU Edge that you saw in my VCL file. It has Edge 1, this endpoint, and Edge 2. And the same is here for the US, and that is hosted on all machines. So we have a, did we just make a mistake? Yeah, that is reflected on every single Varnish node, so on all 4 of them, both in the United States as in the EU. Remember when I told you that we needed a network load balancer, not an application load balancer, because we wanted to terminate the TLS locally? Well, let's do that. This is certificate information, a whole lot of it. Certificate to make sure that all the connections can happen over HTTPS. And we have a tool installed here. I'm going to show you that tool called Hitch. This is a running process. And Hitch is a highly performant TLS terminator, TLS proxy that we developed ourselves that will allow you to terminate TLS records. It is super fast, it's built for the job, and it's very flexible. So we just provisioned some certificates there. And the final step is to create a template for error messages. This is just a stupid HTML template that replicates, that uses the same styling, same CSS. But the thing is that this reason string will be replaced with the actual error in Varnish. This is just styling. So we're at the end of the regular provisioning. What we need to do now is just run a couple of commands to make sure everything is started properly. We start by extending the behavior of the VCS agent. So the VCS agent is a service that runs on the machine that collects statistics and that sends them to a central point. In this case, that should be the Varnish custom statistics server. But as you can see, it only logs it to localhost. So we need to change that, and we will right now. So I have a command to do a little bit of find and replace magic. Don't mind the syntax, it's a bit complicated. It just changed that. So if you look here, it is now pointing to VCS DIY-CDN varnishsoftware.com. And all the nodes will have that, and they will all send your statistics there, which will be convenient. The following thing we do, the last actual file change, is we're going to override the behavior of Varnish. By default, this is the runtime process with all the runtime options of Varnish. By default, it uses malloc, which is memory allocation. So it stores objects in memory only at 256 megabytes. That's not enough. That won't do. And we will need MSC here. So again, do some find and replace magic. And if we open the file again, it has been replaced with MSC and then its configuration file. And here is how we tie it all together. We've prepared everything. All the files exist. Configuration is here. And the final thing I'll do here is I will now restart all the services on these boxes. And ladies and gentlemen, we just built a CDN in about 45 minutes, but we'll use the last 15 minutes to demo what we've got. So the first thing I could do is like perform a curl call. For those of you who don't know, curl is an HTTP client on the command line. So if I do localhost, I'm getting actual outputs. Our CDN works. So let's try this out. Ariana, would you be so kind to share the www record? See if we could get it done here. Here we go. This is our CDN actually. I am in Belgium, in the EU, and when I refresh, nothing really happens, and that's good because the timer doesn't need to update because it's cached. What is also pretty interesting is I have a VPN service here, so I'll enable that. So bear in mind, I'm going to www. If you go there, most of you are European, I guess, you will see EU origin. I'm enabling my VPN, and I'm choosing United States here. It's connecting to the US, it has connected. So when I refresh, it fetches play the video, you see everything. Oh, look, it still caught it. Oh, it switched over from, because of that switch with the VPN, it switched over from US to EU, and everything seems to work just fine. Now I have some debug commands to show you a little bit of information. because there's lots of information exposed through headers that you might be unaware of. So I'm going to go to this command line here. Let's clear it. When I run curl on the www record and I sort the header output, you will see that it starts with an H header here. This object has been in cache for 107 seconds, and it can remain in cache for 3,600 seconds. This is a cache control header that the application developer, in this case me, sets, and Varnish respects that TTL. It didn't override it. And then there's other meta information like we've detected the country code to be BE and Belgium, and the origin is Edge 1, and the actual storage origin is EU origin, and this content is stored on disk. Now, I can do that again and filter on X edge or origin. So now we're on Edge 2, Edge 1, Edge 1. This is the load balancer in action. This is the load balance switching you back and forth. I'm going to do something else. I'm going to grep for H, or I'm just going to, sort all the headers and take that m3u8 file. So hls main.m3u8. When I sort this, you see that the age is 0, and it will always be more or less 0 because if you remember correctly, we set the TTL to a single second. So after a second, this will be invalid. But what is also interesting is that Varnish storage is set to memory. We're not allowing this to be stored on disk. So this is a debug header I set. That is quite convenient. The next thing I'll show you is eventually, I promised you I would do that, how to invalidate the cache. So I have this call here that I will run. It's a regular curl call, but the only thing I'm doing is using -x purge. That indicates that we want to use the purge method, not the get method. So when I run this, it says purged on EU Edge 1. So let's try this out for a second. I'm here on the EU origin, and the timing, let's see if that works. Second, bear with me. So I'm going to go to EU Edge 1. That timestamp has been updated. I'm going to do it again to prove my point. Change it. Timestamp is updated. The problem is, if I go to Edge 2, I'm seeing a different value. So that's a bit problematic, but we'll sort that in the end. The next thing I'm going to show you in terms of purging is how to tackle Y key purge, because I promised we do things on a tag basis. So it's very much the same call. The only difference is that we're inserting a custom request header called Y key purge. And in this case, we're removing everything from cache that was tagged with HLS. And in the end, you can see that 220 objects were removed from cache. That's probably because my video was running for a long, long time. There was a lot of things happening in the cache. So that's how that happened. I could have the flexibility to say, hey, I don't want Y key purge to tag everything in regards to HLS. I just want the page to be removed on Edge 1. So I'm here, let's go to Edge 1 again. I'm refreshing, nothing is happening to the TTL. I'm executing this, and the TTL has been updated, so it has been removed from cache. 2 items have been removed. So let's add a little bit of flexibility, because again, if we go to Edge 2, the TTL will be entirely different. So what I'm going to do now is I'm going to show you how the broadcaster works. I have a command for that. Looks like very much the same command, but instead of going over HTTP, I have the specific port 8088, and that is the broadcaster. When I run this HLS invalidation, it will reply with every single server that received that request. So both EU Edge 1, EU Edge 2, US Edge 1, and US Edge 2 have processed this. So if I go to Edge 2, timing has been updated. Let's see how good that works. I'm going a bit on a limb here, 4943. And on the other one, 4943 as well. So 2 things happened. One thing is I invalidated a whole bunch of servers. Then I requested content, but because of Varnish high availability, it was immediately synchronized to the secondary server as well. And I can prove how that works too. But the first thing I'm going to do, or the last thing I'm going to do in terms of invalidation here, is I'm going to throw in this command. Looks like the same command, also on port 8088, but with an extra header, X broadcast group. You might remember that, the broadcast group, it's in our inventory. We're only going to invalidate things in the EU. And as you can see here, only Edge 1 and Edge 2 were done. So that's how Y key works. You're probably not going to do that in curl. You're probably going to embed that into your application logic and tie this into your CMS. So imagine we're going on Edge 1 and we're going for blah. Blah is a piece of content I've never accessed. And when you go for it, you see it's not stored in cache. It was just empty. But when I do it now, it's been in cache for 4 seconds. I'm going to go to Edge 2 now. And normally, I would have to get H0 as well, because there's no way I've ever accessed this on Edge 2. But when I run it, I see it's been in cache for 17 seconds, which means there was replication in play that did this. So that's that. That's how that worked. I'm going to show you some more features on the www here. Is that we have geo-blocking in place. So if I do geo-block, there is no problem whatsoever. As soon as I go back with my VPN to the United States, and I refresh, in Belgium. Another of these artificial features that I showed you in VCL, I'm going to showcase now. So I'm refreshing. Too many requests. Big problem, too many requests. So that's how that works. The next thing I'm going to show you, because we only have about like 8 minutes left, is Varnish Live. So Varnish Live is a dashboarding tool that relies on Varnish custom statistics. And I could see that plenty of people are playing the video here. This comes in real time or semi-real time. It has a delay of 2 seconds, so 2-second buckets. And we're processing about 70 megabits worth of data. Pretty damn interesting. It is a web application under livevarnishsoftware.com, but it's also available in the App Store on iOS as a native app, but also for Android on the Google Play Store. We see that we have 1,888 requests per second. Things are going well. We have a couple of spikes here. Are there errors? No, none, no errors whatsoever. And I am curious how many of you are on there. So at this point, we have about 9 people who are on that page. But I'm interested in the transfer rate too. So we saw that we have a little spike of 140 megabits, and it has dropped down to 35 now. What I'm going to do is I'm going to cheat a bit, and I'm going to throw a whole lot of load on it. So I'm using AB, which is a benchmarking tool by Apache, and I'm going to send 5,000 requests with a concurrency of 25. So I'm doing that right now, and you can see that this will massively spike. So we're at 280 megabits a second, 300 megabits. So you can see that this has an impact. So for me, this is just showing off the tool right here and showing you what we've got. You see that it drops now. So that's how that goes. It is configurable. I have this data source here where I can point to any data source I want. This is what was in the VCL and uses the Varnish custom statistics. So this is a very convenient tool, both for sysadmins, but also for decision makers. If you have this either as a web application or a mobile app, you can see at any point the amount of requests on your platform, errors, concurrent users, and that gives you a pretty decent insight as well on transfer rates. So that was Varnish Live. I have about 5 minutes left, and I will dedicate those 5 minutes to the so-called traffic router. I've hinted towards it once or twice. This is a traffic router. It is not in Amazon's data centers, nor is it on Azure. It is something that you can host on premise. We have it right here. This is routing software that we've developed ourselves. It is already being used by some of our clients, but it is unreleased in general availability. We're still tuning it a bit, but it's very convenient. It behaves in a similar way as the GeoDNS, but with that difference that it doesn't work based on DNS, but on HTTP redirections. But it also does detections, either based on your location in the world or the device you're using. So let's see if I'm still correctly signed in. No, I'm not, so I need to log in first of all. And this is router.varnish.cloud. This is more presented as a service, but in reality, this is just software you can use, install locally, may redundant probably, and this will accept all these connections and route you through the correct location. I'm already going to copy that. That is the name and the fully qualified domain of our router. So if I click it, I have multiple endpoints here. All the endpoints seem to be healthy at this point. I have an endpoint for the EU, one for the US, and I associated tags with that. We have an EU tag, a US tag, and our US endpoint is also our fallback location in case the US or the EU router falls over. This is fully configurable. You can go to settings, and I can define where the router should route EU traffic to. So this is that endpoint, you're probably familiar with that. And this is the health probe to figure out if it's healthy enough to redirect. And I'm associating this endpoint with the EU tag. Same thing applies to US. When I show this to you, there's the US equivalent right here. So that should do the trick. And it's associated with fallback tag and the US tag. Now these tags matter because these tags form the many-to-many relationship between rules and endpoints. As you can see, there's 3 rules here. Each of them have tags. Let's take the first one, for example. The condition for this rule is if the continent of the client that is accessing this is North America, then this rule applies. And we assign it to the US tag. Same for the EU. If your continent is Europe, well, then this rule applies and the EU tag is called, which will then call that endpoint. If none of it applies, we'll take this one. If no condition is met, then we just go to fallback. This is our fallback. But as you can see, you can click here and you can define any other rule. You can go for all or any conditions. It has AS numbers for your IP range, location of where you're at, on which continent you are, which country, city, which device, platform, operating system, browser. So plenty of configuration options. So now I'm going to show this in action. Let's try this out. So when I would do a curl -s-i of this router software, it would redirect me. So this is something you'll probably know, HTTP 302 redirect. Well, it would redirect me to a certain location. Which location? The EU location. It knows this because I'm in the EU, and it did that. Like it says, you're in the country Belgium, which is in Europe, and they tracked my IP down to the city of Torhout, which is not 100% correct. Like I live about 15 miles from there, but it's close enough. So it knows a certain amount of things. So if you would do HLS and then main.m3u8 for the video player would be redirected to the EU. Or if I would enable my VPN again and get myself into the United States, if I clear the screen, I would do exactly that. Let's make them count. If I go back to www and I modify the URL to router, and if I take the page source, you will see that the source of my video all of a sudden no longer is the local system, but it points to router DIY-CDN varnishsoftware.com, HLS main.m3u8. And from the previous demo, you've seen that this will cause a redirection. So I will inspect, take you to the network tab, filter on all requests. When I start playing the video, all these things happen. Now, what you will see, I'll pause this, a lot of duplication. 2 is twice, is in that list twice, 3 as well. What is happening is if I click the first one and I look at the header, this is the traffic router responding and telling me to redirect to this one, which is what's happening here. This is EU DIY-CDN. This is what we were redirected to. And that works quite well, very simple. You don't have to rely on any DNS caching because if you're familiar with DNS, it can fail on you real quick and it would cache all over the world and would store certain values that you don't want. So what I'm going to do now is I'm going to keep playing that video for a couple of seconds. And now I'm going to take down the EU, not the entire system, but I'm going to go to the router and disable this EU tag. So this rule is no longer valid. So when I keep playing this video, there's a little bit of lead buffering time there. I'm going to take you to exactly the spot where it switches over. Right here. So right now, everything is EU, 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 and all of a sudden we're in the US because of buffering. And did you see any glitch? I didn't see any glitch. It was like seamless. We're going to do the exact opposite again. We're going to re-enable that rule. Enable the the EU rather. Take you back to the video, and it's still loading, loading, loading. If I take it forward a couple of steps, there should be that transition point again. It's right here. So we're watching the video from the United States, but EU is back up, and boom, we're in the EU, not a single glitch. And that's how the traffic router works. The traffic router was built for videos. The reason why we say that it's ideal for videos and maybe not that suitable for websites is because of the redirection. Your URL would all of a sudden change in the address bar. We're not sure if that's a desired outcome for you, and it might even have an impact on your SEO. So that is it. It's 5 o'clock where I'm at, and we've just built a CDN, ladies and gentlemen. So I hope by now that you believe that if you build your own CDN, you can have tons of flexibility for a predictable cost and predictable stability. If you want to know more about all the things I've talked about, and you already have an existing relationship with us, please reach out to your contact at Varnish Software. If not, just go to varnish-software.com. All the information is there. If you want to get in touch with me personally, I'm the Tech Evangelist here. That's my email address. I'm also available on Twitter @Thijs. And with all that being said, there's still a little bit of time of Q&A, but I do want to thank you for being with me here today. I know I had a lot of fun. I hope it was worth your while as well. And if there are any questions, I would be happy to answer them for another 5 minutes. So please put them in the question tab. So let's have a look. I see a couple of questions right here. Let's have a look. Question by Carlos Abaldi. Any reason to avoid terminating TLS in the AWS NLB? I wouldn't really have any specific opinion on that in terms of architecture, but I did it for my use case because why would I do all this TLS setup in Amazon if everything is pre-prepped on my server? There is no real reason. You can actually terminate TLS if you want to on AWS's ALB or the equivalent for Google or Azure or even Oracle. We're even in the Oracle cloud, and it'd be no issue. So it was just for convenience. I don't hold anything against terminating TLS on that load balancer. Question is, will we be able to get the video from the webinar? The answer is yes, you will definitely get that. See if there's other questions. Your system only works for video content, not websites. That was a question by Damien here. Well, in fact, everything that is HTTP we can handle. Like I told you really at the beginning of the presentation that our primary use case has always been websites. I just wanted to highlight something special with video because it's a very nice use case. I wanted to divert from the typical web acceleration. But no, it is not only about video. We can definitely host websites as well. And as I've shown you with that web page you've seen where the video was embedded, that was cached as well. So everything that is HTTP, from a CDN to an API to a video streaming platform to a simple website, we can handle it. If it speaks HTTP, we do it. Yep, that's about it. That's about all the time we have. We want to stick within the time. Don't want to waste your time. I would like to thank you again for being here. We'll stay in touch with you. If you have any questions, do not hesitate to reach out. And with that being said, have a pleasant evening.